Okay, here's a question on loan repayments, and there's quite an interesting part for part B when you're part of the way through repaying the loan. So let's dive into it. Let's zoom in on the details here. A little bit blurry, but we should get through it. Part A. So found the amount Anya must pay each month. So going straight for this. Okay, so it's a loan repayment. There's 5,000 to buy a car. There's a monthly payment being made. It's over 3 years, something in 3 times 12, and the interest rate is 4.1%, and it's compounded monthly. All right, so we actually just going to go straight to the TI Inspire, and all of those bits I've highlighted in different colours, we're going to feed it into the finance solver, and we'll interpret the answer there. Okay, so let's just bring the finance solver up, make this a little bit bigger. So document, insert, let me just get a calculator in there, and then menu, finance, and finance solver. Okay, so N is the number of payments that we're going to make, so it's the number of repayments. Well, I think that's 3 years, monthly payments, so that's 3 12s of 36. I think that's right. The interest rate, this is always the yearly per annum interest rate, that's a 4.1. The present value, well, this is the loan amount that you're receiving, right? And you're receiving 5,000. Comes into you, so it's a positive. The payment is what you're trying to work out, so we'll just leave that. The final value will be 0 because you want to pay the loan off. The payments per year, you're making 12 payments per year, and the compounding for the interest is stated there clearly right as 12. And then we go and solve. We press enter on the payment, and you can see it's negative 147.84, and that's money going out from your possession, so it's going away from you, so that's why it's a negative. So let's just write that down. 147.84. So for part A, it's a negative, let me put my pen on, negative 147.84, so therefore it's a payment of $147.84 per month. And it is always worth just putting some of the details down, right? CPY, PPY, just putting some of these numbers down that you use. Okay, so just to copy the calculator down, I mean, I've obviously missed quite a few things off there, but certainly a 12 and a 12, the present value, the final value, the payment. Okay, so this is what we're solving for. Final value 0. Present value here was the 5,000 coming towards us. Okay, so it's always good if you just jot down those notes down. It'd be really helpful. And I suppose we should just check that payment's made at the end. Okay, that's just a default. But now it's part B that's the interesting one. All right. Okay, so let's have a look at part B. Where's my pointer? There we go. Calculate the amount still remaining to be paid after Anya has been making payments for 1 year. Okay, now there's 2 ways of doing this, but only one way is actually correct. So let me show you both ways of thinking. This is the incorrect way, this is the correct way. The incorrect way is thinking, well, actually I've made 12 payments of 147.84, and then I'm going to do the 5,000, subtract the 12 times 147.84, right? Kind of makes perfect sense, but I'm afraid it's a little bit more complex than that. So let's just put the answer down for that, and let's see what happens. So let's press escape here. We'll do 5,000, subtract 12 times the 147.84. Gives us a nice answer of, so the remaining is 3225.92. But the actual way of doing it is using the finance solver. So let's get that again. Menu, finance solver. And now here's the thinking behind the finance solver way. So the number of payments we've made is 12. So that's pretty obvious. The interest is 4.1%. Okay. The present value is the starting value for the loan, which was 5,000. But now what we're going to do is we are going to make the payments going out of negative 147.84. But now we're going to solve the final value. What is the final value of this loan after making the payment of 147.84 for 12 months? Okay, so everything else stays the same. We're just changing that N. So I'm going to go back to the laptop now. I'm going to change the N12, and I'm going to change nothing else basically. It's just the 12 we've got to change, and of course the PPY, CPY are both 12. And let's go and solve for the final value. So the final value here is, well, it's negative because it's money that you still owe. So this is the amount of cash in one lump sum that you would have to pay if after 1 year you stop payments. This is the total amount you've still got left to pay. So in fact, the total amount left to pay is 3401.07. So it's not a great deal of difference, but it is different, right? It's still more left to pay than the way you calculated it this time. So it's a subtle difference, but it's quite challenging, right? So now for part C, we then use this answer, right? So part C is find Anya's new monthly payment for the remaining 2 years of the loan. Okay, so what's happened is she's switched finance company, and now, unfortunately, the interest rate has gone up to 5.3%. So what we do is we take this final value here of 3401, and we now pop this here. This is, imagine the actual current amount of her loan. So we 0.07 here. The final value we want to be 0. The interest rate is changed. Now this is the 5.3. I think it's still compounded monthly, right? Still compounded monthly. Now we have 2 years left to repay. That's 24. And now we've got to work out the new monthly payment. And of course it's gone up a little bit. So for part C, it's gone up a little bit because of the increased interest rate. So it's a $149.67 monthly payment. So I hope that helps tidy up some of the confusion between, what's left to pay on the loan. It's called a reduced balance amount, and it's quite complicated because as you pay a monthly payment, the balance comes down, but then a little bit of interest goes back onto the loan, so it goes up. So it's constantly coming down, then going back up a little bit, going down, going back up a little bit. The only way to really solve these, what's left to pay on the loan, is by using Finance Solver.